हेलो।
हेलो।
बाकी के सब कहाँ है? क्योंकि डेटा सेट तो मेल पे आ गया है। क्लास ऑलरेडी स्टार्ट है शायद से।
नहीं, वो ऑफलाइन थे ना शायद। सर ऑनलाइन कनेक्ट नहीं हुए होंगे।
ऑनलाइन कनेक्ट नहीं है क्या?
हाँ, हो जाएंगे थोड़ी देर में। हम्म।
Good morning, everyone. Online people.
Good morning.
Good morning.
So today we hope to do two things. Or rather, I should say three things. One is we have to finish the last part of decision tree, which is the cost complexity parameter. And then we have to do decision tree regression. And we'll see why decision tree regression is not a very good method or a algorithm to do regression techniques. Okay? Why decision tree does not fit always. And then we will do random forest, of course. Yeah. No source found. ये क्या हुआ? Why is it not working?
Sir, click Windows P and duplicate. Sir, click Windows P and duplicate the screen.
ये सब कर दिया है, done. It must be a loose contact. Okay, so today we are going to do two things. One is the cost complexity parameter or the complexity parameter. Can anyone tell me what is the use of CP, complexity parameter? Online? I think we covered this topic, at least the theory part. What is the use of CP? CP is CP determines the quality of the split. Okay. Online, is my screen visible? Hello.
Yes.
Okay. Okay, so in the last class, we saw the decision tree can split based on the most significant feature, right? And what is that significant feature based on what parameter is that? If I have 10 features, it splits on the most significant feature, isn't it? So which is the most significant feature? I do not know. So it is going to determine that based on some factor. What is that called? Non-linear is the type of the feature. But on what basis does decision tree split on a feature? For example, it is going to split on X8. So why X8? Why not X2? So what is this? How does decision tree come to the conclusion that X8 is the most significant feature? Based on what factor? Correct. It is information gain plus entropy. Okay. So it is going to find out for every feature what is the gain with respect to Y. X2, what is the gain with respect to Y? And then determine which is having the highest gain. So highest gain means that that feature becomes the first feature to split. Okay, so if X8 has the maximum information gain, so it is going to determine, it is going to split on X8. Okay, now if X8 is the significant feature, on what value it is going to split? Okay, so if it is a categorical data, it is going to split on all the values. For example, if X8 has 3 values, yes, no, maybe. So you will have yes, no, and maybe. So how many records are there where the Y value, where the feature is yes? So we'll get the result. For no, result, maybe results. Okay, then for each result, it is again going to do the split on the next feature, and likewise it goes. Okay. Now in this, the more features you have, the more depth it has. Okay, depth means the height of the tree. Okay, we call this as depth. Now, one of the disadvantages of a decision tree is more features lead to overgrown trees, and overgrown trees lead to overfitting. So how can I control the overgrown trees? That's why I asked you last week, anyone who likes gardening. Okay, so what do you do with the overgrown branches? You cut it. Okay, so when you chop off the extra branches, what do you get? You still get the main tree. The remaining things are of no use. So we can do the same thing in decision tree also, and that is called as complexity parameter or CP. In Python parlance, we call this as CCP, cost complexity parameter. Okay. Now, how do I determine this CP value? Now, if you remember last week we discussed, I have a Y variable. Let's say it is binary class 0 and 1. Now I have my first feature. Let's say X8 is the most significant feature. So yes, no, maybe. Now, based on this split, can I determine what is my Y variable? Can I guess? It may not be possible. So after the first split, my cost complexity parameter is going to be very high. Okay. Now, after X8, I'm going to, let's say my next parameter is XY. So XY, let's say it has two values. Let's say yes and no. So now I have two conditions. X8 equals yes and XY equals yes. Now with this, can I determine what is my Y variable? Now this guess is going to be better than the previous guess. So now in the second iteration, my CP is going to be less, let's call it CP2. This is CP1. So CP2 is definitely going to be less than CP1. That is the complexity of identifying the Y value is higher, is lower compared to the previous one. That means I can make a better choice. Now, if I do a third iteration with the next feature, let's say X2, and here it has a value less than 10, greater than equals 10. Now the condition is X8 is yes, XY is yes, X2 is less than 10. Now can I make a better decision? Definitely. So my CP3 is going to be less than CP2, which is less than CP1. Okay. So now which is the best complexity parameter? The best complexity parameter is the one which is having the least value. So here CP3 is the least. Now there are chances that when I take my next parameter, I can get, let's say I'm taking X10. Now X10 can give me a number which is going to be greater than the previous one. There are chances, because more features means more difficult it is for you to make a decision. Okay. So there are chances that CP4 can give a higher value and CP5 can give a lower value. So your choice is now between C3 and C5. So how do you determine that smallest CP value? Okay, so if I take C3 as a smallest value, anything after that, you are going to chop off. So you want to trim that tree. If C5 is the smallest value, after C5, you chop off the remaining part of the tree. That is called pruning. So where do you want to prune? How much you want to prune is determined by the parameter called cost complexity parameter, or simply say complexity parameter, or CP. Clearly, the idea behind this. So definition, cost complexity parameter determines quality of split. Number two, it is going to give you the value for splitting or not splitting, pruning your decision tree. Now, how to do this in Python? How to write the code? Now, there is a parameter called CCC alpha. CCP alpha, sorry. If you look at the decision tree signature, if you do dir and decision tree classifier, you will see one of the parameters is CCP alpha, just like we have min splits. Okay, so this is one of the parameters. So here you have to define this value as, if I give, let's say 0.001. So it will find the CP value as 0.001. Anything beyond this, it is going to ignore that tree. Okay, so how do I determine this value? So I'm going to take the training data. I'm going to take the test data. I'm going to do a cross validation and find out the CP value of this and the CP value of this. What are the values which are lying very close to each other? Okay, so let's say that I have, this is training and this is testing. So one value is lying here, one value is lying here. Then I have one value lying here, one value lying here. Then exact same line, one is here, one is here. So which is going to be my cost complex or complexity parameter? If I look at this distance, it is on the higher side, so this won't come. Now between, so let me put this as 1, 2, and 3. So CP for the training. So this one and this one, this one and this one. So here you can see both are same, isn't it? Now, which one should I take? I should take the minimum of these two. So minimum value is going to be, if I say this one, so from this point onwards, the trees will be chopped. Okay, so that's the idea behind doing a complexity parameter implementation. So this is one of the hyperparameters. The default value, I think, is 0.005. I'm not sure. I think this is the default, but you can override this value by determining what is the complexity parameter for the given data set. Okay. Any questions on the CP?
Sure. For example, if I get a CP value at x3, which is minimum in top 3, like x1, x2, x3, and x4 is higher than the third value, and later on, but in x5, I get the more smaller value than x3. But I have chopped up the tree, so it will affect the model.
So what you will get? So let's say that I have my model 1. Okay, this is without pruning. This is without pruning. Now you take this model and do the prediction. So you get P1. Now the pruning is done on the model. Okay. So I have model 1 prune. So I take this as the input, determine the CP, and then I prune it. So I have a pruned version now. Now, if I take the pruned version, so this is prune 1, then I do the prediction. So I get P2. Now, which is better out of these two? Is P1 better or is P2 better? How do you determine that? Based on accuracy, precision, recall, and F1. Okay. So find out which is giving you the best results. So if P1 is giving you better results compared to the pruned version, that means pruning should not be done, because you have chopped off significant information. Okay, so you have 3 conditions. The result of P1 and I have P2. So this is better than this. So it means you take the model as M1. The second scenario is the P2 model is better. That is, let me put this as M1P. Okay, so the pruned version is giving you better results compared to P1. So which model will I use? M1P. Now there can be a situation where both the models are giving identical results or near similar results. For example, if this is giving you an accuracy of 79.3, this might give you 79.4. Okay, so when you have similar results, then you can either take M1 or I can take this. Clear? But generally, pruning is done when you have a huge number of features, not with 3 or 4 features. Okay, pruning is usually done when you have a very high dimension in your data set. Clear? Okay, so let's the theory. What? Okay, shall I send you the code for the pruning part? अरे आ गया. Yes, I've sent you the code. Just forward कर देना सबको. So online people, I'm sending you the code for the pruning part. You don't have to write it. Just 2 lines of code. I'll explain the code, very simple. Okay. So before I run this code, you open the code that you wrote for decision tree classification. That is an E. coli code. And run the code from the starting till the last part that we did. That is the model that we built. The first model that we built without hyperparameters. That is, the model name was M1_ENT and M1_Guinea. You build these 2 models and do the prediction. Done. So now if you look at the results, the accuracy of entropy model without complexity parameter is 80%. And the accuracy of the Guinea model is 83% without complexity parameter. Fine? All good? Sabta ho gaya? Online? Have you finished till this part? Okay. Now let's go to the code. Code mil gaya? Have you got the CP code? Okay. Now, ideally, you should have this code after the prediction. Okay. Only then you will be pruning the tree. So that is why I have included it right at the end. So I'm taking the cost complexity parameter for which model? I'm using the Guinea model. Okay. So the model becomes the input. So the function name is cost complexity pruning path, which takes 2 parameters, your training data, which is X and Y. Now this training, pruning path will give you 2 values. What is the CP value and what is the impurity value? Okay, so I'm getting those 2 values here, alphas and the impurities. But we are interested in only the alpha value. Alpha is the complexity parameter value. Now we have to determine which is the best value based on cross validation. Now look at this line. What is this line? DTC, decision tree classified. This is what we built just now. Now here I am taking only one hyperparameter, and that is, what is the complexity parameter? Okay. So build a decision tree model. The input is going to be only one hyperparameter, which is CCP alpha, which I'm getting it from all the alphas for the given model. Clear? Now let me run this loop. So first, create this list of classifiers. And then this is going to build the list of models for every complexity parameter. So if you have 25 values, you will have 25 models, right? So you can see here, these are the list of decision trees based on the complexity parameter. So kitna hai dekho, it is around 20 or something. Fine. Is this clear? Now, the next step is using these models. These are the different models based on the cost complexity parameter. Now, using these models, I am building a training score and I'm building a testing score. Okay, so this is a cross validation that I'm doing to identify the minimum CP. Okay. So for every model, I'm getting the training score, and for every model, I'm also getting the testing score. Now I'm going to plot them to identify which is the minimum CP. So in Matplotlib, there is a type of plot known as step plot. So step plot means you will get the plot something like this. Okay, this is called step plot. So now let's run this and we'll see how to identify. Okay, very good. So you will get the graph like this. This is called as a step graph. Now you will see here, the blue color is called as the training and the orange one is the testing. So we need to find what is that value where the training and testing distance is the minimum. Okay, now let's do a quick analysis. Can I take this point? No, because the distance is very high. Can I take this? No. So find out that point where the distance between the training and testing is minimum. So if I take this, is this minimum? No. Can I take this?
No.
Yes. No.
We're in the first starting.
So now notice the axis. If you look at the x-axis, the value is increasing. The CP value is increasing. Okay. And if you look at this value, the accuracy is maximum. So we need to find out where do you have the maximum accuracy of the training and testing and also the minimum alpha or the minimum CP. Okay, so that is why I said, look at the distance so that it is minimum. So if I take this point, accuracy is high, alpha value is also low, but look at the distance. Okay, so I cannot use this. Now, if I take this point and if I take this point, so between these two or between these three, which is the best value?
So the first circle above there, one orange and blue line are colliding little. So can those be considered?
So this is your analysis. There is no right answer that, okay, it is coinciding, so I should take this. If I take that, you will get the result accordingly. So what will happen if I take this point? The tree from here will be pruned. If I take this point, the tree from here will be pruned. If I take this point, this portion will be pruned. Or if I take this point, this portion will be pruned. But if I take this point, what is the accuracy? 70%. So may not be the best pruning parameter. Okay, so now for just for the sake of it, if I take this point, because the accuracy is also high, the CP value is low, or I can take this because there isn't much difference in terms of the distance. So I can take any one of these two. Now, what is the point here? What is the value? How do you determine it? So it is lying somewhere between, now if I draw a line, so it is between 0 to 0.05. Okay, so this CP value is somewhere between 0 to 0.05. So you can take a range of values to find out which CP is giving you the highest accuracy. That is one way. The other way, now just move the cursor and keep the cursor here and look at what is the X which is changing right at the bottom. You can see the X and Y value changing. So if I keep the cursor here, you will see that the value is 0.017. Okay, 0.0177, which is in between 0 and 0.05. Clear? So for the, based on this, I'm going to set the value for complexity parameter as 0.0177. So now let's close this. Come back to the code. And here, I have given 0.012, that was with the different set of data. So here it is 0.0177. So change that. Okay, this line. CP 0.0177 based on the complexity parameter. Now line number 184, I'm going to build a new model where the complexity parameter is what I have determined just now. So I'm creating a model called M1 Guinea underscore CCP. because my base model was the Gini model. Now do the prediction. Now do the comparison. Which is better? Gini model was giving how much? 83. And look at the pruned model. It is giving 85.7. So which is a better model? Pruned. So this is what pruning can do. समझ में आ रहा है? The difference between a non-pruned tree and a pruned tree. Online, any questions from anyone?
Sir, can you tell me the statement to change graph size?
Fixed size. You have to use the subplots and then fixed size. Plot कहाँ पे आ रहा है? Where is the plot getting displayed? Fixed size. Fixed size equals, then get the becomes 2. So it's going to give 15, 10. Yeah. Now run this. So there is the, okay, reduce that number. Done? Okay. आपका? What about you? Done? Yes. Online, any questions? Okay. So now we'll do the decision tree regressor. Now remember that decision tree is primarily a classification algorithm. Okay, they are part of the CART, C-A-R-T, classification and regression trees. So they are primarily meant for classification related problems, which can also be used for regression. It's not the other way around. A lot of people make this mistake. Okay, it is a classification algorithm which can also be used for regression. Now, it always does not give you a very good result. Yeah, Ankita, I'll share this code. This always does not give you the desired result when you use a decision tree for regression. Okay. So we are going to try out one example and see if for this particular data set, is decision tree a good choice? Okay, if the results are good, then we are going to use it. If you feel that the results are not that good or it is not giving me the right values, it is not the good choice. Okay, so open the linear regression data set. We are going to use that same data. Okay, and do the initial data reading and all that. You can just copy paste that code. Linear regression.
We have paper data and cards data.
1 second. Let me show you which one. The one that we did here. This one, concrete. Just copy this code. And we don't want everything, okay? Just the basic code. We are not going to put the heteroscedasticity and all those things, okay? Those things you can include it later on. So here idea is, how can we use decision tree in our regression? So I'm going to remove the heteroscedasticity check line from here. Remove the PyLab. Remove pre-processing. Remove the Box-Cox transformation library. So just have these. So import pandas, NumPy, stats models, matplotlib, Seaborn. And in the model selection, I'm not going to do any k-fold cross-validation. So remove that also. And then of course we need the RMSE and MSE. Okay, now here in the model, since we are building two models, One is the OLS model, which we have already done. Then compare that with the decision tree model. Okay. So from sklearn.tree, import decision tree regressor. So there we had DTC, decision tree classifier. Here we'll have DTR, decision tree regressor. Okay, so this is the new one. Then read, okay, let me save this file first. Okay, so file name, concrete. Okay, I need to import the libraries first. Okay, so read the data. So the data shape is 1030 records and 9 columns. So these things will remain exactly the same. You can rename the column names. Okay, now just include these two lines, check for 0 and check for nulls. You can remove this part, summarize the data set, not required. ये वाला फर्स्ट जो हमने किया था ना लीनियर रिग्रेशन, सेम कोड, ओके, कॉपी पेस्ट किया है. And now I'm creating a y variable called CCS. This will be used to split my data into training and testing. Okay. Then check for normality. This function, this you can remove. Just remove the entire function from here. You can put this later on. Okay, not now. The next function is plot charts. You can remove this also. Then we have this function called split data. This also we can remove. And just have this line. Train X, test X, train Y, test Y. Just have this. Okay, so instead of data, you will have concrete, capital Y, concrete of capital Y, and the test size will be 25%. Done till here? So find out what is the train X and train Y. So 772 records in training and 258 records in testing. Splitting the code. Splitting. Okay. Huh? You have the files. All the files in place. Yeah. How many of you require the files that we did in the class? You missed online में नहीं थे? Okay. But ये videos देखे आपने? Okay. Okay. I think you missed a couple of sessions actually. 2 weeks you missed. Can you share your mail IDs, please? And online, anyone who wants the files, can you please share your mail IDs? Yeah. KCP RO C KES KCP ROCK. एक काम करो ना, टाइप इट हियर. Okay, Ankita, 1 second. I'm sending this. NKITA Ankita J. ए आराम से. ANKITA Ankita J Purane Yeah, just key the email ID. Yeah, समझ में नहीं आ रहा तो not after 1 minute.
मैं अभी वही बोल रहा हूँ, ये जो अभी दिया ना, the resident data, वो पहले वाला केस
आज जो लिया
हाँ लिनियर इम्प्लीमेंटेशन
कौन सा तो सीपी वाला वो तो लास्ट वीक का
ब्राउज़र में जॉब आज के वही ब्राउज़र में
नहीं है पहले भी बोला
अकाउंट आप लोग कैसे देगा कैसे कम्युनिकेशन कर पा रहा है अरे देखो हम पहले
हो गया
लास्ट मॉडिफायर
केशव पार्थ ओके @gmail.com ओके ओके और किसको चाहिए फाइल यश का तो है आई हैव योर मेल आईडी ये है ना हाँ टेल मी योर मेल आईडी इधर टाइप इट आपको
हाँ मनीष तेजस और इसके वो 58
तेजस
और भी वाले
वो बना
भी मुखारी
JASBORADE
58 in the rate
What about you? How much you have?
Neither word pattern is a good tool himself, but my page person. It doesn't really
Okay, regression ka we are doing it now, so I'm not sending it. Okay, so at end of the day I'll send it. So this has decision tree. Sorry, linear regression, logistic regression, decision tree, classification as of this morning. Okay. Ankita, please check your mail. I have sent you the 3 files. Okay, have you all completed till line number 37? Sorry, not 37, line number 47, sorry, splitting the data. Okay. Okay. Now, I have not included the validations because validations you can do it later on. The objective here is to show how to implement a decision tree regressor. Okay. So your code should end here as of now. Okay. Now we are going to build the model. Or I should say build models. The first model is on the OLS and the second model will be the decision tree regressor. Okay. Now, if you look at the code, I have a function called build model. So remove that function. Remove this. And take only the main part, which is the OLS part. And you can call this as M1 underscore, or you can call this as model underscore linear regression. Okay. And just remove all these lines, that is heteroscedasticity, all these things we don't want, cross validation we don't want. And remove the prediction also from here. Okay, so remove everything. Just have this function called best fit line because we will be using this. Okay, other things remove. You can insert those lines later on. So build the model. OLS model is this. And I'm going to include one more model for decision tree. So model underscore decision tree equals decision tree regressor. Now here, just like a decision tree classifier, we have a decision tree regressor where the criterion is MSE. If you want, I can include the other hyperparameters like max depth, minimum samples. Okay. So let's say minimum samples in the leaf. Okay. I want to have at least 3 records. Now, how many features do we have here? There are close to 8 features. So if you want to stop or restrict the depth of the tree, so max depth. So let's say I want to restrict this to around 6. Okay, so these things you can fine tune later on. And then fit train X, train Y. Okay, now compile both the models. So this is model linear regression and model decision tree. Done online? Have you finished this? People here in the class?
जो अपने प्रिंटर्स में जो कॉन्टेंट ड्रॉप किया है तो वाई से वन मींस एक्सेस रिकॉर्ड वन पे जो रिकॉर्ड है जो डिलीट हो जाएगा ड्रॉप
हाँ भैया हाँ ये वाला ना
फर्स्ट वन
ये वाला हाँ तो y में जो कॉलम नेम है CC वो ड्रॉप करो
और
एक्सेस वन मींस आई एम ड्रॉपिंग ऑफ कॉलम बस ड्रॉप फंक्शन जो है इट सपोर्ट्स बोथ ड्रॉपिंग ऑफ रोज एंड कॉलम्स
नेक्स्ट वन वन जीरो
conc of y means concrete data set से I am taking only the y value
जो प्रेजेंट है के बाद ड्रॉप होने के बाद जो डेटा है वो है नहीं इसमें
नहीं ऐसा नहीं है सी सी जो ट्रेन टेस्ट फिट जो फंक्शन है what is the input to this function? तीन input है इसका okay one is what is y x what is the y sorry okay and then what is the ratio sorry not ratio but either the train size or test size कोई एक दे सकते हैं so we generally give test size ठीक है now what is the x in this case हमारे पास है ना x अलग सा कुछ नहीं है y अलग सा कुछ नहीं है okay everything is mixed as a data set which is called concrete तो concrete में क्या क्या है x भी है y भी है so how do we pass x and y separately one way is I can do conc underscore x equals create a variable and then conc y equals so two variables okay now good programming respects usage of variables जो आप derive कर सकते हो उसको create नहीं करना okay so how do I derive the data from the existing ones so how do I pass the value for x
ड्रॉप करने
तो drop करना है so when I use conc dot drop what am I dropping
वन
the y variable y में क्या है
CCL.
CCS. So drop the y from where? From the columns. Axis equals 1 means columns. इसका output क्या है?
X.
Everything but the y. So you will get x. पर ये data पे store नहीं करेगा. Okay, this is only the output. So now this becomes. How do I pass the value for y?
Point C.
We concrete as it is here. Y भी है. So if I do concrete of y, तो ये क्या देगा? Only the y value. So that is what is this. Test size ratio क्या है? If I give 0.25, 0.3, the data is split into 70-30 or 75-20. Clear है ये? हो गया? Model build हो गया? Okay. Now we will do the predictions. So first prediction is on the OLS model. So we will write prediction underscore LR equals M underscore LR dot predict using the test data. So we have test X. Okay. Now, if you look at the original, that is the actual test Y. So this is the actual test Y, and P underscore LR. This is the predicted value. Now, if you want, you can restrict the decimals to 2. Okay. So in the prediction, instead of having this, I can have NP dot round and give here. So now you have 2 decimals in the predictions. Now same thing, do it for the decision tree regressor. Predictions for decision tree equals NP dot round. The model for decision tree is M underscore DT dot predict on the test data and then comma 2. Now, if you look at the values, so you will have these numbers. Sounds good. So now for the linear regression, I have built 2 models. OLS model using linear regression, decision tree for linear regression. Clear? Now the question is, which out of these 2 is the better model? How do you determine that? Accuracy. Tejas, लीनियर रिग्रेशन पे 2 मॉडल है मेरे पास अभी, तो कौन सा मॉडल बेटर है? हाउ डू यू डिटरमाइन?
R square values रहेंगे ना कॉमन
R square डिसीजन ट्री में R square कहां से मिलेगा? ठीक है, you are very close. MSE. Okay, we have to find the MSE or the RMSE. Okay, अभी दोनों का RMSE MSE निकालो, find out which is having a lower value, and then we will have some fun. Whether RMSE low RMSE, is it necessarily, does it mean a good model? Okay, find out which is having a low RMSE. So here you can create one function called get. You can just put get error, actual and predicted. Now there is a function called as mean square error. We have already used that. So mean square error will give me MSE. So mean squared error, actual data and predicted data. Okay, and then RMSE is going to be how do you find RMSE?
Root of mean square.
Square root of. Okay. So NP dot square root of MSE. Okay. And if you want, you can round this off to 4 digits, and I can round this off to 4 digits and then return MSE and RMSE. Okay, now you can put MSE for linear regression, RMSE for linear regression equals get error. So what is the actual data? Test Y. What is the predicted value for the linear regression? It is P underscore LR. And then MSE for decision tree and RMSE for decision tree equals get error, test Y, and predicted value for decision tree is P underscore TT. Okay, so now we have the 2 errors. Now let us print the values. So print RMSE /n/t OLS equals /n/t decision tree equals dot format RMSE underscore LR RMSE underscore DT. So for OLS, it is 10.2 and for decision tree, it is 8.1. So which is a better model? According to the RMSE, it is decision tree. /n/t, I hope you know the significance of /n/t.
Yeah.
You like that? Can I conclude decision tree is the better model?
No.
No. OLS 10.24, decision tree 8.10. Can I conclude DT is a better model? It is less. But we have not seen the results. No? We have only checked the errors. But what about the actual predicted value? Have we compared those things? So let us see how the values are. Now you can write data frame to store actual CCS and predicted CCS from the two models. So you can create a data frame called results equals PD dot data frame. The actual data is, what is actual data? Test Y. What is the predicted data from decision tree? P underscore DT. Then what is the predicted data from, sorry, DT will come afterwards. Pred underscore linear regression. I'll put test OLS. How much is the OLS? P underscore LR, correct? Now study the result and tell me if the predictions are good or not good. Yes, PG. Which batch? 0. I think it's on the other things. Are you able to see the results in the data frame? Okay. Now tell me, do you see anything odd in the output?
The output differs too much from the actual values for certain. Like for actual it is 13.34 at one record and the predicted is 29 for OLS.
Okay.
And for DT it is 12.
In actual, some values are like let's say 51.0 and predicted are higher than that.
Okay, that is not unusual. I'm looking at something which is very peculiar in the output. Are you able to see anything like that? Nothing? Okay, let me just print out the first 20 records. Now tell me. One second, I'll just zoom this so that it is get a better view of this. Zoom in here. Anything unusual? No? Okay. Online, Ankita, have you finished with the predictions? Okay, look at the predictions or look at the actual values for the first two records. 38.07, 18.03, right? What is the predicted value for from the OLS model? 29.45, 23.19. What is the decision tree model predictions? How much is it? 35.44 and? Now tell me, do you see anything unusual?
For values below I think 40, it is like 35, yes or no.
Continue.
So yes or no, if it is less than 40, the decision tree value might be 35.44. And more than different values.
Okay, very good. So if you look at these predicted values, they are the same. 35.44, 30.544. Maybe there is another record which is having a similar value, 35.4. There you go. Okay. Now there is a zero probability that a model will give you the exact same digit for a float number in terms of prediction. So here it is actually not doing a regression, it is actually doing a classification. If the conditions are met, the predicted value is going to be 35.44. Now, why 35.44? Because the average of that tree is 35.4. Okay. Look at this value. See, one more 35.4. 52.00, 52.00. But why is predicted OLS not behaving in that way? If you look at the values, 29.4, 23.1. But why is OLS not giving a result which is like this of a decision tree? OLS has a formula. Okay, this does not have a formula. DT में क्या है? DT has a path. Okay, OLS has a formula. So when it follows a certain path, the end result is going to be an average because it is a regression. So irrespective of the values, if it fits that path, the values of the predicted data will have the same number. That is why you are seeing these duplicates. So now tell me, can I use decision tree as a regressor? You see the difference, how OLS works, how decision tree regressor works, and how just based on RMSE, we cannot find out which model is good unless we study the results also.
So this can be called as false positive.
This is not a regression. This is a regression, not a classification. How can you have false positives in regression? This is a valid value. There is no doubt about it. This is also valid value. The question is, do you want to accept these predictions? समझ में आ रहा है? Now, will I get the same trend if I take some other data set? I do not know. Okay, for some data, maybe it works better. But for this data, I probably will not use a decision tree as it is. Okay, first of all, I have not done any of the validations. Multicollinearity, I have not checked. I have not done feature selection. So if I do all those things, then if I use a decision tree regressor, maybe it will work. Okay, but this is the implementation part, how to apply a decision tree regressor on your. Okay. क्या तेजस समझ में आ रहा है कि ऊपर से जा रहा है? ऊपर से जा रहा है? No, I guess we should first clear all these doubts. नहीं तो अभी आगे के सब ऊपर से ही रहेंगे, विच आई डोंट वांट। क्या नहीं, व्हाट इज दैट यू हैव नॉट अंडरस्टूड, लेट्स गेट दैट।
अभी जो एक्चुअल वैल्यू जो प्रेडिक्शन वैल्यूज है डेविएशन में, और जो अपने प्रेडिक्शन में जो एवरेज देते हैं, जो अपना डिसीजन रहता है, उसके संबंध में जो अपना आउटपुट है वो निकलता है। और लीनियर में जो लीनियर में कैलकुलेशन में वैल्यू कैसे फाइंड आउट करे और सिग्निफिकेंट कैसे दे वो वैल्यू को वैसे प्रेडिक्शन में।
ओके, लीनियर रिग्रेशन में प्रेडिक्शंस कैसे होते हैं?
प्रेडिक्शन उसमें टेस्ट करके हम एमएससी
नहीं मैम, एमएससी तो बाद में आएगा। एक टेस्ट डेटा है मेरे पास, ठीक है, वो टेस्ट डेटा प्रेडिक्ट कैसे होता है?
पी वैल्यू निकालते हैं, पी प्रेडिक्ट निकालते हैं टेस्ट एक्स से।
क्या निकालते हैं?
पी वैल्यू प्रेडिक्ट वैल्यू निकालते हैं टेस्ट एक्स से।
हाँ, वो कैसे होता है, दैट इज द क्वेश्चन। व्हाट इज द बेसिस ऑफ प्रेडिक्शन? क्वेश्चन समझ में आ रहा है? See, I have एक डेटा सेट, राइट? इसको मैंने स्प्लिट किया, ठीक है, मॉडल इससे बना, अभी मॉडल प्रेडिक्ट करेगा, राइट? अभी ये प्रेडिक्टेड रिजल्ट के साथ मैं टेस्ट रिजल्ट्स कंपेयर करूंगा, ठीक है? दिस इज द फ्लो। ये प्रेडिक्शन कैसे होता है विथ रेस्पेक्ट टू लीनियर रिग्रेशन, ओएलएस मॉडल या लीनियर रिग्रेशन? ये दिस पार्ट ये कैसे होता है? स्प्लिटिंग हो गया ना, स्प्लिट हो गया, मॉडल भी बन गया। नहीं, मुझे डोंट टेल मी द सिंटैक्स, वेरी सिंपल लैंग्वेज में बोलो, ये प्रेडिक्शन होता कैसे?
ट्रेन डाटा
ट्रेन पे तो मॉडल होता है, वो बन गया। So you need to get these basic concepts, ठीक है, नहीं तो शुरू से करना पड़ेगा। See, predict happens on which data? Train and test. डिसाइड करो, टेस्ट पे होता है, तो ये इस पे अप्लाई करेंगे और फिर ये रिजल्ट देगा, फिर कंपेयर करेंगे, राइट? ये प्रेडिक्शन हाउ डज इट हैपन, ऑन व्हाट डज इट हैपन? टेस्ट पे होता है। हाउ डज इट? बेस्ड ऑन द फॉर्मूला, फॉर्मूला बनता है ना, when you are building a model क्या है? With respect to linear regression OLS model क्या करता है? Model will build this formula. क्या है formula linear regression में? Y hat equals A plus है कि नहीं? What is Y hat?
Line.
Let me see.
Line.
क्या line?
Intermediate.
See, you can afford to make all mistakes here, not in interviews. Y hat is my predicted value. Simple. मुझे क्या predict करना है? That is Y hat. What is X?
Test value, actual value.
किसका?
जो हम जो डेटा दे रहे हो.
उसको क्या बोलते हैं?
Trainings.
This is the input data. Okay, so prediction के लिए this is the test input. What is B?
Intersection.
No, ऐसा जब मत बोलो. I don't know maths. Imagine.
Slope.
तो B क्या है?
Slope.
क्या slope क्या होता है?
Y minus जो value देते हैं.
वही बोला, I don't understand maths. If you tell me slope, मुझे I have no idea क्या है. B corresponds to the weight of this particular feature. ठीक है? ये इसका weight है. What is A?
Coefficient.
Coefficient of what?
Input.
वो हो गया ना इधर. This is the coefficient of input, which is B. B is the coefficient of input. What is A? A is the constant term. ठीक है, कांस्टेंट का क्या मतलब है? Sorry? हाँ, तो what is the significance of that?
Change with predicted value or
How the?
it's not going to change.
It's not going to change. Okay.
The prediction, the comparison of predicted value. If changes over there.
Fine. That is why it is called constant. It doesn't change. This actually represents the mean. Okay. If nothing is there, how do you make a prediction? Y equals C. Okay, which is also known as the intercept. Okay, y-intercept. Y-intercept is nothing but the mean value. So कैसा होगा y-intercept? So this represents when you have an equation like this, do we have this line? No. We have the best fit line. Okay, that is the significance of this. So regression का क्या है? It is the influence of the mean value plus the features. Okay, what is the influence of both these? I think the first class we saw, isn't it? When I have a data which is representing some number, let's say sales figure. So this is data point 1, 2, 3, 4, 5. Predict the sixth value. Can I do the prediction? I can do. How do I do? Take a mean of this. वो क्या है? This one. Now the next question is, can sales be predicted only by this, or the sales can be done, or sales predictions can be done using other factors? So other factors क्या है? Okay, so that is what is reflected in this equation. समझ में आ रहा है? तो linear regression, how does it get predicted? By using the formula. Now decision tree में क्या है? Decision tree का formula क्या है? There is no formula. तो decision tree का predictions कैसा आ रहा है?
तो splitting होता है उसमें डिसीजन जो
Correct.
एवरेज निकला तो मीन निकला.
So in decision tree, it follows the path. So if my first feature is this, and second feature is this, and third feature is this, okay? So based on that path, it is going to determine the average value. So there are chances when you have less than, equal to, or greater than equals, multiple records will have the same value. So वो यहाँ पे हो रहा है. समझ में आ गया? नेक्स्ट वीक तक याद रहेगा कि परमानेंटली याद रहेगा? Fine. So now tell me, is this a good model or not a good model?
No.
Not a good model. So this is how you build a decision tree regressor. Now we'll quickly do the best fit line. You can retain this code as it is. And here plot best fit line test y. Predicted is P underscore LR. The third parameter is model, so I'll put OLS. And the fourth is error term, which is RMSE underscore LR. This is DT, decision tree. Okay, so I have taken the same function जो हमने पिछली बार लिखा था. So this is the best fit line for model OLS RMSE 3.2. Now from this, you can make out the actual versus predicted. दोनों एक ही में कर लिया मैंने. Now look at the predictions for the decision tree. Do you see any difference in the two graphs? Look at these points.
Arrange along the mean. Arrange along the mean.
They are more or less, they are linear. यहाँ पे there is some variation. Whereas the OLS model was more spread. So is this okay or not okay? Definitely not. Okay.
This can be termed as singularity, like it is showing the same.
Same नहीं है ना, it is similar in nature.
Okay.
Same मैंने क्या होगा, एक ही dot पे सब point होगा. That is similarity. Similarity is not for predictions. Similarity is for the data. Okay, are you able to plot it? So that finishes decision tree. We'll take a break. 11:20 हुआ है, 15 minutes, and we'll start random forest next. Online, who's there? Ankita and Manish. Manish, yeah. We'll take a break now. We'll meet in 15 minutes. working on algorithms and all. वो सिर्फ एक, that is one of the rules. Right from data analysis, working on data, cleaning, all these are part of data scientist. Data analysis is not a simple task, by the way. बहुत difficult है वो.
नहीं मतलब मैं बोल रहा हूँ कि मैं रिपोर्टिंग कर रहा हूँ, ठीक है, मेरा थोड़ा दिमाग में लगता है प्रॉपर कोडिंग लाइन से, तो इसलिए मैं थोड़ा आई डोंट वांट टू गो इनटू प्योर कोडिंग.
Okay.
तो इसमें ऐसा डेटा से रिलेटेड ऐसा कोई रोल है क्या?
See, if you have a technical background, data analysis becomes easy. See, roles का तो यार, it is entirely based on the organization. Very specific to organization. Now what? Okay. वो तो development में हो जाएगा. That is development. हाँ. हाँ.
कोई भी हो,
हाँ.
अगर हम कुछ बोलेगा,
हाँ.
तो मैं हार्ड कोडिंग नहीं करूँगा. ये मतलब मेरा पर्सनल है, ठीक है. तो if I don't want to work there, what is the alternative? जहाँ पे मैं long run से I know strong SQL, ठीक है, SQL I know, Python I know, technical चीजें I can learn easily, because I can grasp, because मेरे पास technical skills है. और मैं ऐसे फील्ड में काम करता हूँ तो उसमें बिजनेस फ्लो मेरे को पता चलता है, तो आई हैव लिटिल बिट टेक्निकल फंक्शनल नॉलेज, बट मेरे को टोटली हार्डकोर कोडिंग में नहीं जाना. So if I can get into consultant roles where you take care of the business side and you also manage the technical. Pure programming में नहीं है, so you understand the technical things, but you are not actually coding.
Project management.
नहीं, project manager का definition भी काफी अलग होते हैं. You can get into program management where you can design the implementation strategies. The technical आएंगे, but not from a programming perspective. Timeline, not just the timeline. What are the technical things to use? Those kind of things. Okay. दूसरा है, like we said, project management. Okay, project manager is expected to know technical things. उसका definition ही अलग होगी. पहले it was pure MBA किया है तो by default project management. Now it is completely. Other area that you can consider is data science. Data scientist. See, that is the misconception. It's not about just coding. This is just one part of it. खाने में सब मसाला है नहीं है ना. So it's a combination of everything. You can call it anything actually. Machine learning engineer क्या करता है? What one company does, other company may call it. So yeah, fancy names don't go by names. Always read the job description. करना क्या है? Basically, मेरे concept clear है. Like मेरे हिसाब से कि I cannot go further in pure hardcore development. क्योंकि मैं पिछले 6 years in IT, उससे पहले colleges and UG part-time jobs की, तो भी pro development नहीं, तो नहीं करना. तो वो मैं stress नहीं लेना. तो बिना pressure रहता है क्या? What kind of पहले मैं web development, तो initially I started PHP.NET नहीं समझ में आता. जब उसको debug करने आते थे, तो it was like इधर से नहीं आ रहा, उधर से नहीं आ रहा. Initial बहुत हुआ. एक टाइम के बाद धीरे-धीरे समझ में आता है कि आप ये कर सकते हो. But वो टाइम इतने टाइम बाद आ रहा है कि होप्स खत्म हो जाती है कि इसमें आगे ग्रो हो सकता है। तो देन आई मूव टू बैक एंड, लाइक तो कंपनी जब कॉलेज खत्म हुआ तो फिर वो कंपनी मिली, मैं एक्चुअली में जॉब मिली, देन आई वर्क एज अ बैक एंड एससीपी डेवलपर। तो मेरा बहुत अच्छा ग्रोथ मिला उसमें, ऐसा नहीं है 6 से मनी वाइज भी ग्रोथ मिला और नॉलेज वाइज भी ग्रोथ मिला, दोनों वाइज ग्रोथ मिला, बट स्टैगर्ड हो गई दोनों। अगर मैं अभी मैंने उनको बोला कि लाइक आई वांट टू क्रॉस इनटू फंक्शनल, लाइक एज अ टेक्नो फंक्शनल, तो दे वर नॉट पुटिंग मी देयर। उन्होंने उससे पहले 2 साल मुझे डेटा माइग्रेशन में डाला, एंड दैट टू लाइक हाँ बिजनेस के साथ मेरा इंटरेक्शन होता था, बट एट द एंड ऑफ द डे एक लाइक देयर वर 2 सिस्टम्स, वन वाज एसआईडी एंड वन आरडब्ल्यूसी। जब तक एसआईडी चल रहा था I was having this inspection, files कौन सी चाहिए, डेटा कितना कैसे करना है, वो सब चीज मैं करता था और एट द एंड ऑफ द डे मैं फॉर्मेट में फाइल प्रिपेयर करके देता था। तो दैट टाइम आई वाज थिंकिंग आई एम लर्निंग समथिंग, बट वो वजह से कोलैब हो गया हमारा, देन आरडब्ल्यूसी के उसमें मुझे कोई काम नहीं था, मेरे पास ऑलरेडी सारी चीजें थी, आई हैव टू जस्ट पॉपुलेट द डेटा। और बाद में वही फाइल प्रोवाइड करने लगे क्योंकि उनको मैंने ऐसे नीचे दे दिया था प्रोग्राम एंड एवरीथिंग, तो दे स्टार्टेड गिविंग अस द फाइल एंड सेइंग ये फाइल स्टोर कर दो, दैट्स इट। तो
हाँ वो
मेरी
मोनोटोन
स्टार्टेड हो गई थी, तो दैट मैं मुझे बोला कि मूव टू टेक्नो फंक्शन। हमारे यहाँ ओटीसी पीटीपी एक्सेसिबल से एरियाज होते हैं, हमारे टू कैश पोकर टू पे ऐसे एरियाज होते हैं, बिजनेस के छोटे छोटे प्रोसेस होते हैं। तो मैंने मोस्टली ओटीसी के एरिया में काम किया था, और कैश में तो मैंने बोला तो ओटीसी प्लस अडाप्टर को आता है, तो अगर टेक्नो फंक्शन में तो इस पर डाल मैंने मैं 1 साल और फाइट हुआ, ये हुआ, स्विच किया, स्विच में ऐसे मतलब जो एक्सपेक्टेड थे ऐसे नहीं मिला, तो फिर मैं चेंज नहीं किया, मैंने एक भी बोल दिया, फिर मैंने मैचअप कर दिया, कंपनी में ही मैचअप हो गई, तो मैंने चेंज नहीं किया भाई। ये फिर लॉन्ग रन मतलब भाई
currently मुझे कंपनी
मैं
accidentally have some data science team
इंटरनल प्रोजेक्ट जल्दी शिफ्ट नहीं करता,
हाँ वो तो है,
वो तो मैनेजर्स वो तो लाइक जो करना कर लो, मैं भी करूँगा ऐसे वो चीज इसमें मेरे को जाना नहीं है, लाइक कि लॉन्ग रन में रियली समझ वो चीज में बात में नॉर्मल बात करता हूँ उनसे, लाइक सर ग्रोथ स्टार्ट हो रही है, कुछ समझ मतलब लॉन्ग रन में अगर मैं एज अ मैनेजर भी बनता हूँ सेम कंपनी में, ठीक है आप मेरे को मनी दे रहे हो, ये मनी इज इम्पोर्टेंट, बट लॉन्ग रन में क्या करना है, कुछ और भी करना हो, मैं स्टैगर्ड हूँ, मैं फंस जाऊँगा, मेरे पास ऑप्शंस नहीं रहेगा। बट थियोरेटिकल नॉलेज गेन कर करके कितना इंसान गेन करता है, सेंस ग्रो करना पड़ता है। थियोरेटिकल मेरे को मीन स्टैक भी पता है, कॉम्पिटिटिव भी पता है, थियोरेटिकल आई कैन कन्वर्ट द केस को नॉर्मल जैसे मैं रीड कर सकता हूँ, बट उसका एक्चुअल इंप्लीमेंटेशन क्या है, इससे पावर भी है, लाइक हमारे कोर्स में आ गया है, तो एवरीवन नोज इट्स अ विजुअलाइजेशन टूल्स, डेटा एनकोड करो, ग्राफ प्लॉट करो, इट्स डन। टैबलू सिमिलर वे वैसे ही काम करते हैं, बट हाउ टू यूज दैट वो उतना डिटेल्स में मतलब कि प्रैक्टिकल उसका नॉलेज नहीं है। थियोरेटिकल यूट्यूब से देख के हम समझ जाएंगे डेटा सेट है, ये एंटिटीज है, मैं समझ जाएंगे, दैट जस्ट फॉर द थियोरेटिकल, बट जब इम्प्लीमेंट करने जाओगे आपको इश्यूज आएंगे, तब आपको एक्चुअली पता चलेगा कि इसमें कितना एक्टिविटी क्या है, इसमें एन नंबर ऑफ लाइंस आते हैं, ये लिंक नहीं है, इस तरह से ये डेटा इधर फ्लो नहीं है, तो वो सारी चीजें हैं। तो फॉर जस्ट
one thing is जब आप कुछ especially when you're learning these kind of things outside your company, एक तो we have restrictions in terms of access the databases and data, तो जो भी डेटा हमको मिलता है we make the best use of it. The second one is the network or central server या database, if we have you won't have, that is another thing. So that's why most of these things are offline.
yeah,
So there's a big difference between the learning part and the actual work. But if you know how to work on it, बाकी थोड़ा इधर plug and play तो चलता ही है. But if you know the majority of the stuff, how to approach a problem, then other things really don't matter. For example, if you know how to work with Tableau, BI is easy. Power BI. The implementation part is similar. I want this graph. Okay, Tableau ऐसा है, Power BI will have a different approach. So that way, focus on the learning program. And other thing regarding your growth, if you feel you are stuck, or the options nahi hai and you want to do something, then I guess you switch either within the company or move outside. क्योंकि वो comfort zone एक बार set हो गया ना, it's very difficult for you to leave because money plays a big role. I have seen so many people who are in this situation. इसलिए मैं 5-6 साल पहले मैं सुन रहा हूँ, my friends are saying March में I am resigning, then I will get into training. It's been 6 years and they are still with their managerial jobs. It's very difficult to leave that comfort zone.
Especially when you are getting money.
क्योंकि आपका experience बढ़ रहा है, that's nothing else is happening. You are not developing skills. It's a big difference between developing skills and gaining experience.
That's the only thing I try to personalize my revision skill. Like within data जब मैंने 2 साल काम किया ना, there were n number of discussions with client कि ऐसा क्यों नहीं, फिर मेरे को उसमें पूरा SAP का पूरा बिजनेस फ्लो बनाना पड़ा. ये ऐसे नहीं, ये ऐसे आता है सिस्टम इस तरीके से. तो मुझे डेटा आपको इस तरीके से आप मुझे दो या मैं आपको कन्वर्ट कर दूंगा. तो मतलब डेटा में ये करो कि डेटा में सिर्फ एक चीज नहीं है, उसमें आपका वैरायटी ऑफ चीजें हैं. अगर मैं इंग्लिश दूसरा दूं तो इट्स लाइक स्टक नहीं है. अभी तक तो एक प्रोसेस तो कर लिया है SAP का, तो हाँ वो स्टक में देख रहा है. ऐसे में और भी अलग अलग चीजें हैं जो मेरे को सीखना है. लाइक बेसिकली मैं ऑर्डर को किसी एरिया में कर रहा हूँ और डिफरेंट एरियाज हैं, बट वही है मौका मिल रहा है और मांगने पे वो दे ही रहे हैं. वही सब में सारी लेना है क्या तो वही है. इसलिए मैंने पूछा कि अगर अपार्ट फ्रॉम कोडिंग हार्डकोर कोडिंग से बाहर निकलना
The data science में hardcore coding नहीं होता. You have to reach the predictions and do business implementation. तो उसके लिए you have to write some code. इससे ज़्यादा I don't think there is much coding unless you want to become a Python developer. वो अलग है.
डेवलपमेंट टाइम
सर अभी हमने जो मशीन लर्निंग मॉडल्स पे लिखना है, तो ये तो डिजाइन फ्रॉम डेवलपमेंट perspective. What about this time?
Yeah, this is not a development. That's what I'm saying. It's not development. Python development.
हाँ, जैसे कुछ अभी हमने जो किया है ना वो
We have done programming.
we have
It's not development. It's programming from a ML perspective.
so not in this उससे काम नहीं.
Real-time programming is totally different. You'll be writing classes and all these things. Not huge implementation. Interacting with the database, connectivity, stored procedures. That is development.
सर अभी हमने यहाँ पे सीखा वो that is only let's
This is programming with respect to Python programming with respect to
हाँ. तो अभी हमने when we are in linear logistic and decision trees, right? So we have worked on those algorithms. So we predicted based on the existing data set. Now let's just take a simple example. If I want to deploy my algorithm, then how shall I work and sim data?
See, अभी deployment का there are different techniques to do it. There is a framework called Django. You can call it different names. It's Django. The Django है, then you have other class है, then you can also do it with as a as a daemon process. So these are well-known systems. That daemon process, this is typical back-end process. Unix पे किसी ने काम किया? We work on Unix. ठीक है, करेंगे. So Unix पे you design something called as automatic scripts.
Cron jobs.
Huh?
Cron jobs.
Cron jobs, correct. Okay. So आपका जो model है, that can be executed as a cron jobs.
But we have worked with one data set. So you remember last time I requested you, can we have some unseen and we can work on them. So you said, yeah, we can delete the file. But how in case of real life scenarios?
See, real life में वही है कि your model is fixed. Okay, once you are done with the modeling, the model fixed रहेगा. Now what will change? Input will change. ठीक है, अभी इनपुट के लिए मान लो I have a directory structure like this, ML some process input. ठीक है, तो I have a directory structure where my data will be has to be read from me. So your cron job जो file है उसपे the input is mapped here. Okay. Then the execution is also mapped that which model to execute, and after that, where to store the result. So let's say I have another ML proc1 predict. So my predictions will be stored in this directory, for example. Okay, and then what do you want to do next? So all these things are defined. So this keeps running. Let's say every 10 p.m. every night. So वो ऐसा schedule कर सकते हैं. So this is another way of implementation.
We have implemented this recently.
This is manual.
This is manual. So if I change the data set, so now currently we're working on equal data set. Okay? So if I give some input, like let's say if I give an organizational data, I have to will this work or I have to
work.
So I have to build a complete different.
That is what happens in companies also. I cannot build a sales model and predict big scores. Sales and sales, yes.
Like code base will remain the same, steps procedures will remain the same, only the main context will change.
So how you want to deploy? Deploy will depend again on companies. I can also write on web page, and I can have this, every evening or every morning someone will simply call that script. Read the data, click the button, load the data, do the prediction, show the screen with the results. That is what what do you want to do? For example, let's say I want to do the sales forecast. Okay.
Sir, instead of sales, if we take the concrete example, I build a web page, then what will be the output at the end of the screen? Your
content want the output to be.
Yeah.
So what are we predicting? This?
Yeah.
Let's say that I want to find out what should be my civil strength for a new project. I'm building a project in Tharadi. Okay, it's a 30-story building. Now this 30-story building will have different requirements based on the floors, for example. So my input will be for this project. Okay, what is the super plasticizer? What is the water content, etc. Or 30 different projects. So my data will be based on those projects. So I'll take one project. So here I'm getting some 50 records, for example. So my model is already there, right? So using that model, I'll be passing this as my test data. So this test data will not have any white. Okay, because model is verified. Now I want to see on a new set of data, what is my model recommending, which is this one. So this will give an output of 50 predictions. Now I can decide, okay, this is my predicted value. So now I can take action based on the results.
So by end of the day, your data set has to change. Like whatever.
The data set will not change drastically.
But slight changes.
If your data set is changing, then your model won't work at all.
I mean, same columns, let's say.
Columns have to be the same. Columns have to be the same.
Yes. The rows will change.
Rows will change. But not only that, your data form should not change. When I say form, it means, let's say that there is a column A and there's a column B. Okay, now column A is consistently giving values between 1 to 10, for example. And this is giving only 4. Now suddenly the data supply changes the format. So he is giving me a log format. So A has become log A. And B has become int B. This might create problems, because my data is not trained on that form. So your data cannot change overnight. By process method, you have a meeting, you say the data is going to be changed. Then you say, okay, data is changing, so give me a sample data. We have to test it, build the model, then you change. As a you can do whatever you feel like. You can't work. Even for adding a dot, you have to sit for a just 1 or 2 day meeting. Then you decide, you have a dot. It's not that easy. And first of all, it's to get a permission to edit the document, it will take time. So you have seen all those. You want something, they want something, you won't agree.
What will be the output? Like this strength, there should be.
This is what we and this is what the model is trained to give.
So it will give values.
Because that is what we want. For this particular thing, what should be my strength? I'll get those numbers. So the site engineer will study that and say, okay, this is a recommended thing based on the past. So now let's discuss it with the technical team. And then all those plus minus will happen. Costing, other things.
I know that let's say second example, you said A and B, right? So let's say A is X and B is Y. So based on A, we have to predict B.
No, both are features here.
It's just in general.
In real life, you will never get Y because the system has not seen Y.
Then what pass like
you pass the input. Tell me the temperature for tomorrow. Have you seen tomorrow? What have you seen today? So tomorrow, I can only say that today's weather will have some impact on tomorrow.
So there won't be an error, right? Because the
There won't be an error.
no values in Y.
You will get some number for tomorrow. Now, is that number good or bad? That how will you know? When tomorrow comes, and then when you actually see the number, okay, this is today's number. My system predicted so much. What is the difference? That is what happens. It is like showing your horoscope. You will go abroad. That is a prediction. Will you go abroad? First of all, you have a passport. Okay, prediction में दिखा रहा है based on the trend. Okay, so your decision will be based on what is getting shown. Now it may not be 100% accurate. So that is why data is important. So यहाँ पे passport सब कुछ है, then you will definitely go good astrology.
In time series, can we do something like this?
Yes, definitely. Time series है ना अपना syllabus में. Okay, so let's go to the next algorithm. I think we have time only for the theory. Next week we will do a random forest and SVM, not SVM, KNN. Oh, tomorrow also, na? I thought today was a Sunday. Tomorrow. Okay. Have you seen? Okay, now the idea behind a random forest is it is going to take care of problems that we have in decision tree. Okay. So what exactly is a random forest? It is also known as an ensemble technique. Ensemble का meaning क्या है? Collection. So multiple models are formed. Each model is going to give a prediction. And then we are going to collate the result from each model and then find out what is my overall prediction. That is known as ensemble. So we can say random forest is a collection of decision trees. Now the difference is in a decision tree, you have fixed number of features. For example, 20 features, 15 features. Okay. Now in a random forest, every tree will have the same number of features, but not the same features. Okay. For example, if I decide to build a forest, let's say I'm building 20 trees. So this is one tree, this is one tree. So there are 20 such trees. Now, let's say that in my data, I have the number of features as 15. Okay, there are 15 features. Name, not here, age, height, weight, vision, etc., etc. I have 15 such features. Okay, gender. Now, how does random forest get built? Now, random forest gets built based on a technique called as bootstrapping. Now, before I come to the technical part, let me tell you the problems that we have with decision tree how random forest fixes it, and then I'll explain this part. Okay. Now, decision tree ka biggest problem kya hai? The size of the tree, the depth of the tree, and overfitting. Okay. So that is solved using random forest, because random forest, I have multiple trees and every tree has limited features. So every tree will make a decision and collectively I'll have a better accuracy. Okay. I'll give you an example. I think this you'll probably will correlate. Have you seen this serial called Kaun Banega Crorepati? Have you watched this serial? KBC? Sabne dekha? Okay, now in KBC there is this this option where if you do not know the question, not the question, if you do not know the answer, there is a lifeline that you can use, and that is called audience poll. Right? ये audience poll काम कैसे करता है? What is the working model of the audience poll? So you have this contestant. One, there's a question put to him. Abhi question ka answer nahi pata. So what does he do? Audience poll. So what happens in an audience poll?
Maximum number of decisions.
नहीं होता क्या है?
They'll be voting.
So let us say there are 500 people in the audience. So each person will vote, or rather give the answer. So there are 500 answers here, right? So usme A, B, C, D options rahenge, and each person will give the answer. Now, can I get all 500 answers right? No. So out of the 500 answers, kaise hoga? A, let's say 300 will give the correct answer. B, it will be 100. C, this will be 50. And D, it will be 50. Correct? So now, which is the right answer? A. So the answer is based on what? The majority, correct? So based on the majority, I'm going to find the correct answer. So here majority answer is A. So the contestant will say that because so many people voted for A, this must be the correct answer. Yahi hai na? Game. This is exactly how random forest works. So I have a decision tree, which is a single tree. Now, if this guy has to predict an answer, jo nahi pata, what is the chance of accuracy? 0. Right? So what I do, I build forest. So yahan pe forest kya hai? Audience. How many audience members? 500. Now, how many trees am I going to build? 500 trees. Okay. Now, each tree is making a decision. Now, first tree will say this, second tree will say this, third tree will say this. So, 500 trees. Then collate the decision of each tree, find the majority in case of a classification, find the average in case of a regression. Are you able to correlate what is random forest? Now we'll come to the part how random forest gets built. So this is called as a boosting technique. Sorry, this is called as a bagging technique. So there are a lot of names to it. Bootstrapping technique, bagging technique, ensemble technique. This is also part of CART, that is classification and regression trees. So this is called as the bagging technique. Also called as ensemble. So here if you look at this diagram, this is an ensemble because I have individual trees or individual models. Model 1, model 2, model 3, everything is getting collated. So this is called ensemble. It is also called as bag because each model is considered to be like a bag. You are taking something, so it's a bag of.
The random forest is mode of decision tree.
Sir?
Mode and mode.
Mode.
Like mean, median, mode. हाँ तो एक ही 300 इसलिए हमने वो चुना करेक्ट
मोड कहाँ से आ रहे हैं? We are taking the majority voting. Mode का totally different context. Don't confuse the statistical terms here. In a way, you are right. Mode means the highest occurrence. वो counting पे we can see. But generally we don't call that as a mode as such. Huh?
And for regression, mean or average?
Average. Huh. So we have a random forest, which is a collection of decision trees. So I have a decision tree here, I have a decision tree here, I have a tree here, I have a tree here. Now the trees are selected based on a technique called bootstrapping. Bootstrapping means you are taking random features from the data. Okay, you are taking random features from the data with replacement. This is important. Yeah, with replacement, what is the meaning of this term with replacement? I think we did this during the Python revision. With revision and without revision. With the replacement and without replacement.
Sending the value respective.
Sending the
Value.
Sending the value. Changing the value.
Replacing the existing values with dummies.
See, let's say I have 20 features in my data set. Okay. Now, decision tree is definitely going to overfit. That I know from theory and also from my model, it has overfitted. Now, I want to implement random forest. Now, I'm going to use the bootstrapping technique. So, bootstrapping means random selection of features with replacement. And the second thing is fixed number of features in each tree.
Randomly updating the features.
Fixed number of features in each tree. Number fixed. If I say I want 2 features in each tree, every tree will have 2 features. But the features will be different. So with replacement का क्या meaning है? Let's say that I decide to build 20 trees. Okay, again, these are all hyperparameter tuning. So I'm building 20 trees. So this is tree 1. This is tree number 2. This is tree number 2, and this is tree number 20. Okay, so 20 trees हो गए. Now I decide to have 2 features in each tree. So each tree will have 2 features. So that is fixed. Third one क्या है? Random selection of features with replacement. So how many features do I have? 20 features. So random selection of features. So for the first tree, I can have X5 and 10. Okay. So random selection. So first tree will have features 5 and feature 10. This is with replacement. So that means my second tree can have the feature 5. And let's say it is feature number 2. Next tree, I can have feature number 7 and 10. So each tree will have the same number of features, but features are at random with replacement. So there could be a chance where 2 trees will have the same set of features also. So 5, 10 here also, 5, 10 here also. Okay, there are chances. Now each tree will do a prediction. So this is P1, P2, P3, and P20. So every member of the audience is doing a prediction. Collate their results, find the majority. Now, what is the advantage of a random forest over a decision tree? What do you think?
Size will be small.
Size will be small. Okay, 20 features with 2 features, which is going to give you a better result. Okay, size is small. Number 2, there is no, sorry, accuracy can be better. Number 3, no overfitting. Number 4, there is no need for cross validation. Okay, because internally random forest does a cross validation for you. So, and how does that happen? Now look at the first tree here. There are 2 features. Okay, now how does the data get distributed? I told you about the features. What about the data? So data will be random 70% as training and random 30% into testing. Okay, so for example, I have a feature called age and I have a feature called gender. And this is going to predict churn. So based on these 2 features, at random, 70% training will be selected from my original data. Model is built and 30% will be tested and you get the result. Next, we will have, let's say, salary versus age. Same thing repeats, but here the 70% data could be something else. It need not be the same 70% data. So cross validation nahi to hogi. Clear? Then, so better results, no CV and accuracy, better accuracy. Bias came. No overfitting, correct. And no pruning. There is no pruning. So we have only 2 features, either. So what do you want to prune? So pruning is avoided. Now I told you that random forest is a bagging technique. So there are two techniques when it comes to random forest decision tree. One is called bagging, other is called boosting. Okay, so random forest is a bagging technique. Bagging means all the models the trees. All the decision trees are built in parallel. Okay. Built in parallel means this decision tree are getting built at the same time. So decision tree 2 does not depend on decision tree 1. Okay. So I will not wait for your answer before I make my answer. तूने क्या दिया? A दिया, okay. Nothing. So you make your decision, I'll make my decision. So this is building in parallel. This is called bagging technique. Boosting क्या है? Boosting is build the trees in series. So you make a decision, you tell me, is the decision right? Then I will check, I'll build the next tree based on your input. That is why sometimes boosting is a better algorithm compared to bagging. Okay? So it's random forest is a bagging technique. Now, what are the different hyperparameters that you can tune when it comes to random forest? Number one, how many trees that you want to build? How many features that you want to have in each tree? Can anyone tell me what should be the basis to build the total number of trees? Take a guess.
Total number of attributes.
Total number of attributes. Okay. Any other answers?
So can you repeat the question?
The hyperparameter tuning that I can do is I want to build so many number of trees. Okay, 25 or 16, whatever number, 30. Okay. On what basis will you select how many trees I want? So Komal said based on the total number of features. 30 features, 30 trees.
Combination of features. Like if we have 30, then if we put 2 features in each tree, there will be 15 trees. Like that, based on combinations.
Okay. Any other factors that you can consider?
So which factors are more relevant?
Factors as in
Sorry, which
features.
features are more relevant?
That is a separate topic. That is feature selection. That's fine. You can also consider the total number of records, that is rows. Okay, one is number of features, no doubt about it. You have to, that should be the first priority. You can also consider the number of rows, because more trees you build, you are actually creating number of decision trees. So it may impact your working of your machine. Okay, when you have only 100 records and you're building 500 trees, is it worth 100 rows and 5 features, and you're building 500 trees? Okay, it's a waste of memory. And if you are having, let's say, 25,000 records, and you have, let's say, 30 features, and you are building 1,000 trees. Okay, it is definitely going to have an impact on the performance. So select the number of trees versus features according to the setup that you have. Then what are the other parameters that you can tune? What we learned in the decision tree. Okay. String. Kya string? Height. Okay. So height doesn't make any difference, because if you are selecting a number of features as 2, so you cannot give a height of 3. It doesn't make any sense. Okay. So what you can tune is how many samples that you get in the leaf. So minimum samples in the leaf. How many samples that you want in the leaf node? How many samples you want in the split node? Those things you can tune. Okay. Then I'll just write here other HPTs of decision tree. So random forest follows the cart classification and regression trees. So that means I can use random forest for regression and classification. And just like in decision tree, we have important features. In random forest also, we have a method called important features. So we can select the important features and use them. And one last thing about random forest is what kind of data works well. Decision tree में क्या देखा था हमने? What kind of data is best suited? Categorical data. Here also same. Okay, doesn't mean that your data cannot have numeric data. Okay, but best suited. Now, in case if your data has numeric component, now in numeric component again there are two things. Number one is correlation between numeric data. Number two is, what is other problem that you can have? One is correlation. Other is numbers can be duplicated. Outliers. Okay, these are the two problems that you can have with numbers. Now, when you have correlation in the data, that is an issue. Okay, because random forest can handle outliers very well. Let us say that your condition is mark less than 50, mark greater than 50, for example. Okay, less than equal to 50, greater than 50. And you have an outlier 2500. Will it affect the decision? Or will it affect the split condition? Okay, it will affect both, but not to that extent, considering the other points. Okay, because what is my condition? Less than equals 50, so I'll have some records. What is my other condition? Greater than 50. So 2500 will fit into greater than 50 category. Okay, so that record will get selected. But what happens when I have a correlation? Multicollinearity is something random forest cannot handle. So when we are doing a data analysis, and if your data is having a mixture of numbers and category or only numbers, ensure that there is no multicollinearity in the data. So just right here, ensure no multicollinearity in the numeric data. But does that mean that I should not fix outliers? No. You have to fix if you think it is an outlier. Okay, not all extreme values are outliers. तेजस समझ में आ रहा है? ऊपर से तो नहीं जा रहा ना? Categorical data. What are the points that you should remember in terms of EDA?
Data type.
What data type?
String and object.
No, that is why I said categorical. So it is obviously a
Unique.
बीच में I need to take these classes. Then you will remember.
Let's take an example. If we have yes and no, sometimes it can be maybe. So that goes with our data. That is somewhere relevant. Then if it is irrelevant, then we have to exclude.
That is irrelevant. Okay. Yes, no, maybe. So how do you find whether it is irrelevant or not?
By observing the data.
Okay, fine. So let us say it is relevant. I have the three values, yes, no, maybe.
What is the occurrence of maybe in our data? If it is occurred only once, it won't have any major significance.
So what do you do?
We can exclude it, or we can replace it with, let's say, yes is there multiplicating, so we can replace it with.
Very good. That is one way. So you're finding the count. Okay. So what is one way of fixing the minority? Anything else? What about the other case? When the same value is repeating. Bolo. Singularities. You have to check for singularities. What is singularity? Tejas bolo.
Both are similar. Single column.
एक और बार बोलो.
दो कॉलम है ना. एक कॉलम में सिमिलर वैल्यू आएगी, वो हम निकाल देते हैं कॉलम सिंगुलैरिटी.
कौन से कंडीशन पे?
कोरिलेशन.
कैटेगोरिकल डेटा का कोरिलेशन कैसे फाइंड करोगे? think and answer. No, कोई जल्दी नहीं. Yes and no का correlation क्या है? Can you find out? You cannot find out. Yeah, yes.
More than 80 or 85% single data appears, so we can exclude that column.
Correct. So, जब value it is repeating approximately 85% of more times. So it means that your data is having singularity. ठीक है? 100 में से let's say you have 90 records having the value yes, and 10 records are having value no. So it means that it is singularity. So you can actually remove that column. ठीक है? So that's it in random forest. I mean, this is the theory. I have already shared the data set. So forward kar dena. We don't have time today.
Sir, does random forest take a toll or not?
That depends on the size of your input data and how many trees you are creating. If you have a very small data and you're creating too many trees, or when you have a huge data and you're creating too many trees, then it will make an impact. When you run the algorithm, random forest, tabhi wo trees parallelly it starts creating. So that process, even though internally it implements the parallel processing, but sometimes when you have too many trees to be created, it can be time consuming. So start with a small number and then see deep learning techniques jo bhi hai, they are extremely dependent on the hardware. Image processing, video processing, audio processing. So they require a lot of memory. These things you can do it with a very simple machines. Online, any questions? कोई है ही नहीं online पे.